every December, a fierce debate reignites: real versus artificial. While purists love the scent of pine, over 80% of American households now choose the permanent option. But have you ever stopped to wonder where these trees actually come from? They aren't grown, they are manufactured. In a single industrial hub in China, known as the Christmas Village, factories operate 24 hours a day, 365 days a year, to ensure the world stays festive. But is your plastic tree actually better for the planet? Or is it a chemical cocktail waiting to happen? Today, on Process Sector, we are stepping inside the massive factories that produce millions of artificial trees, from liquid plastic to the final frosted branch. The evolution, from goose feathers to PVC. The artificial tree wasn't always made of plastic. In the late 19th century, Germans created trees out of dyed goose feathers to combat deforestation. By the 1930s, the Addis Brush Company, a firm that literally made toilet brushes, realized its machinery could create pine needles out of the same bristles. Today, the industry has evolved into a multi-billion-dollar sector dominated by two materials: PVC, polyvinyl chloride, and the more realistic PE, polyethylene. While a real tree takes 10 years to grow, a 7-foot artificial tree can be grown in a factory in under 30 seconds. Raw materials and the petrochemical supply chain. The chemical components. The production starts long before the factory floor with massive shipments of raw pellets. PVC, the traditionalist. This comes in giant rolls of thin green film. It is the most common material used for filler branches. PE, the realist. These are small plastic resin pellets. PE is used for real touch trees where the needles are molded from actual tree branch casts. Steel wire. Thousands of tons of galvanized steel wire arrive from local mills. This forms the skeleton of every branch and the central trunk. The primary suppliers are global chemical giants like Formosa Plastics and Sinopec. These factories consume enough plastic annually to wrap the earth several times over. But before the first branch is twisted, the materials must undergo color matching. If the forest green is off by even a fraction, the tree will look like a cheap toy rather than a centerpiece. The step-by-step factory process. The shredding and slitting. For PVC trees, the process begins with the slitter. Giant rolls of green PVC film are fed into a machine with dozens of circular blades. These blades slice the film into long, thin strips. But they aren't just flat ribbons. Another set of rapid-fire knives notches the edges of the film, creating the needles. Imagine a paper shredder that doesn't quite cut all the way through. That's how you get a long fringe of plastic pine. The needle injection. The PE method. If you're buying a high-end $500 tree, it likely uses PE. This process is much more technical. The plastic pellets are melted at 200 degrees Celsius and injected into steel molds. These molds are actually 3D scans of real North American fir or Fraser pine branches. When the mold opens, it reveals a branch that has three-dimensional needles, varying colors, and even woody textures. This is the process sector at its most artistic, using heavy machinery to mimic the imperfections of nature. The branch twister. This is the heart of the factory. A machine known as the automatic branch twister takes two long strands of galvanized steel wire and sandwiches the fringed PVC or molded PE branch between them. As the machine spins at high speeds, it twists the wires together, locking the needles in place. The machine then automatically snips the wire to the required length. A single machine can produce thousands of branches an hour. For specialized frosted trees, the branches move through a secondary booth where a mixture of paper pulp, water, and glue, known as flock, is sprayed onto them to simulate fresh snow. Trunk assembly and structural engineering. A 7-foot tree needs a spine that won't collapse under the weight of ornaments. The trunks are made of heavy-duty steel pipes. Workers use hydraulic presses to punch holes into the trunk at varying angles. This is where the hinged technology comes in. Instead of sticking branches one by one, Modern trees use a hinge system. Each branch is riveted into a bracket, allowing the tree to bloom open when it's taken out of the box. The lighting and quality control. The 3,000-point inspection. Pre-lit trees are the biggest sellers, but they are also the biggest factory headache. In the final assembly stage, workers hand-wrap miles of LED strings around the branches. To ensure safety, the trees are plugged into a stress tester. This system checks for short circuits and ensures that if one bulb goes out, the rest stay lit. A technology that saved the industry from the frustrations of the 1990s. Every tree is then fully assembled on a rotating platform. A quality control officer checks for bald spots and ensures the tip count matches what is printed on the box. If a tree is marketed as having 2,500 tips, it must have 2,500 tips. Logistics and the final box. The compression miracle. The final step is the most impressive feat of packaging. A 7-foot wide tree must fit into a box only 12 inches wide. Massive industrial compressors squeeze the air out of the branches, folding them tight against the trunk. They are then vacuum sealed and slid into cardboard boxes. From here, they are loaded into 40-foot shipping containers destined for ports in Los Angeles, Rotterdam, and Sydney. It takes a village of machines and thousands of hands to create the perfect nature-inspired holiday. While it may not have the smell of a real forest, the engineering behind an artificial tree is a testament to how far manufacturing has come since the days of goose feathers. So, are you team real or team artificial? And if you have an artificial tree, how many years has it lasted you? Let us know in the comments below. If you want to see how more holiday favorites are made, from glass ornaments to candy canes, be sure to subscribe to Process Sector. We'll see you in the next one.